In this video, we'll decide if the series, whose terms are of the form log of n over 2 to the n, converges or diverges. One approach is to attempt to use the ratio test. So we're going to attempt to apply the ratio test to this series. So I should first identify what the terms of the series are. I'm going to call them an, and that's log of n over 2 to the n. Before I can apply the ratio test, I need to make sure that my terms of my series are eventually positive. In this case, as long as n is bigger than 1, all of those terms will be positive numbers. The log of something bigger than 1 and powers of 2 for power, or any power of 2 really, will be positive. So this fraction here will be positive provided n is bigger than 1. When n is equal to 1, the log is equal to 0, so that term's actually 0, but it's not so relevant what happens to the first few terms. As long as they're eventually always positive, I can apply the ratio test. To do so, we're going to apply the ratio test, and we're going to look at the next term in the series. I'm going to look at an plus 1, and that just means evaluate my nth term, but now at n plus 1 instead. So I'll have log of n plus 1 over 2 to the n plus 1. The ratio test says look at the limit of the ratio of consecutive terms and look at what happens as n goes to infinity. So I'm going to take an plus 1 and divide it by an. In this case, when I take the nth plus 1 term and divide it by the nth term, this term here, I'm going to actually be multiplying by its reciprocal. So instead of dividing out and having a compound fraction, I'll multiply by the reciprocal, which is in blue here. There will be some canceling that takes place, 2 to the n plus 1, and that's being divided into 2 to the n, so I'll get a factor of 1/2 when I do that canceling. And I still need to look at the limit as n goes to infinity of the ratio of the logarithms. As n becomes large, both of those logarithms go to infinity, so this form is in fact infinity over infinity. It's an indeterminate form, and we can use L'Hopital's rule. L'Hopital's rule says differentiate the numerator, so I'm going to take the derivative of log of n plus 1, and that's 1 over n plus 1. And then I'm going to take the derivative of the log of n, that's 1 over n, and I get this new limit, and if this one exists, it tells me the limit that I was trying to calculate. So I have 1/2, and now let's simplify this expression here in the parentheses. It'll be 1/2 times the limit, and cleaning up the fractions here, it's really n over n plus 1. And both of these have a degree 1 in the numerator and denominator. They're both linear, and as n becomes large, this will go to 1 over 1, or just 1. So this limit here will be equal to 1/2. Because that number is less than 1, the ratio test tells me that this series must converge. When the value you get from looking at the limit of consecutive terms is small, specifically less than 1, your series is in fact converging.